mutatóját, az nem fog látszani a felvételen. Elmondtam neki angolul is, nem hallgatnak rám. Ha ez lesz benne, akkor a felvételben a mutatás nem látszik. Yes.
Which
No, this one. Yes.
you see your pocket.
Yeah.
My is
Yes, it's stronger, but on the video it doesn't.
on the video.
You won't see it.
Yeah. Okay. Yeah, you use this.
Yes. Thank you.
Okay, so rendben van, kezdhetjük? A technika rendben van, mehetünk? Rendben van technika, kezdhetjük? Okay, so thank you very much. I think we are almost complete. So now we arrive to the second session of this our today meetings, and this is the plenary keynote talks. So first of all, I would like to ask Professor Chen, who, as we heard, he has a very important role in this whole conference. So to deliver his speech, which is titled Progress and Challenges on the Research and of the Trans-Eurasia Exchange and Silk Road Civilization. Thank you. So you have 20 minutes.
Okay. Thanks. On behalf of the co-chair and the Yugi and the Mike, and just I will not for detail for the ATES, but for the progress. That's one. And most as you see for the Silk Road, there's basically 3 Silk Road. One called the Steppe Silk Road, second the Oasis Silk Road, and the third one on the Tibetan Plateau Silk Road, along that's one and the last one and the last one. And from the old capital of China, and from Asia and to Europe to Central Asia, East Asia, Central Asia. This is basically also connected with old civilization, for example, from Egypt and all this area connected each other in the past. And in this area, there are diversity of the landscapes, forest, wetlands, and also the mountain, grassland, desert, and Gobi, and also there are farmer towns and oases in the Tibetan Plateau, the lakes, the glacier, and the east is the early Loess Plateau. That's who connect each other for these areas. This I will be not give a talk in the Yugi has given the detailed talks, and basically you see a lot of the city, town, village now in the desert, and so we need to understand that's why this is a mission, and Yugi has talked about this one, and now I just give virtual for the last few years virtual progress for this one. First the Palaeolithic culture and the humanities. So for the we need to understand the Eurasia continent. For example, for the early human migration, for this is hand axe people before. Most before I said the European not to China, but now see the hand axe people not from the Africa across the this area and to Europe, to China, even to part of the Tibetan Plateau. This is a very advanced people before the modern human sappers. And next one, we sure after cooperation, we also understand the Neanderthal people, and we also find some special technology in China. So the Neanderthal people now we know moved to Mongolia Plateau, more part of the China, and even to the South China. This is a Gina work group one. We find a special called Gina Technology Corporation. So this is published in early published. and the APS. And now we also understand that before our modern Homo sapiens, there are Eurasian continent, there are two groups. One is Neanderthal. Neanderthal is something left side. And then Denisova, we call it Longi people, the red color. All this area with Denisova people. And but expanded to part of the Central Asia, expanded to Indian continent. And Neanderthal also came to much part of the China. So East Asia is much complexity for the early modern human history. This we recently write a paper, give the suggestions. And also you see the modern Homo sapiens, there are two ways to East Asia. One is called blended technology. This is quite clear. But the south part, we didn't know how they moved to China, moved to other area. Recently, we have a paper in the AC University. They have different technology and the plank of the Homo sapiens. They moved, we find from Kiev, from here, and this is the early modern Homo sapiens already in China. This is for the early time, but for the agriculture, this is also quite interesting. This is we see there are some. For example, for the, we use the spatial temporal variation of the passage for crop living stools diffusion along the sea corridor. This is from West Asia, and you see the crop is good this way, and the steppe is good this way, and the land go to the steppe oasis. Sometimes from 4 to 5,000 years in the land through this way to the oasis developed. It is we know more and more clear for the people, for the living stool, how East and West connect each other. And also we see for the farmer, the early farmer, millet farmer on the Loess Plateau, how to the Tibet Plateau. This is a student published there. And already people has some crop use the new treaty, the high production, and many people expansion to Tibet Plateau still use the same lives and even exchanged with the high mountain Himalaya area. They have exchanged the crops and living by lake size. Different life of the people. This is also cooperation this years, and also we need also try to understand the people. For example, for the Aya people from this area, and this knowledge, the war is here, expanded to Europe and expanded Central Asia and some to the Mongolia, even some to China. This group of the people we call the white people or the Aryan people in the expansion that in the world. And interesting is, if you before the early farmer, you see less the Tibet is less archaeology sites, and after this one is more archaeology sites, and two sites is the Gobi Desert in much of the Tibet. You see, after the two from Oasis Silk Road, 4,000 years ago, there's two groups there, and already more and more sites and the people activity in these areas. And in a special area, we try to understand how the people environment affect the people. This is one of my group has done the work. And before, when the climate environment is good and the people is there, hunting and herding in the Gobi Desert area, the mountain area, and but in the 4,200 years, there are very few sites, archaeology sites. That's almost no people is there because it become very dry situation. But when a new group of the people moved to this area, you see there are develop different signals and use the mountain, use the oasis for farmland, the mountain area for herd, and then more and more size when the climate get better, people get a lot expanded and use the oasis, use the mountain areas. This is the group, probably that's why. And the early time, and also we see how the Tibets, where Tibet from, and when the Eurasia continent, the Bali and the median to the west, and the Bali to the east, and the first median farmer is in the low valley. This is the elevation to the valley of the Tibet Plateau, and about the 4,000 years, we use the 3,006 years, we published the paper in size, and people live in the high mountain area for farmer and for the herds. This is because the Eurasia continent contact. Also, the group of understand the evolution and the development of the transport network, the towns. This is two examples. This is the you see in the 500 BC around Iran. The more we understand where the town, where the people live from archaeology side. And in China, in most part of China, you see this is the old capital of China. This new capital Beijing, and you see the more also they are developed there. And we try. In the land, we try also understand the routes we call the Silk Route, the oasis route developed to Central Asia, to West Asia, connect each other quite early. And this is just 100 CE, the sea to Asia. This was done there. And at the same time, when across Eurasia, the big challenge is develop the large desert, Gobi, and the very dry area. This is the only path to this area. And this just beside the large desert area, the cave, called very beautiful arts is there, and the book is there. For a long time, but there are some embodied bad method for this one. We try to understand why should not continue, but we find this is Ba Guanghui's work from Nanjing University, and you see we use the number of the tribal trees and the walls, and you see this just from here to here there are lands and give up for the road because you see for the treasury like the law taxi moisture in the very dry lands. So we more and more understand why sometimes the road connected, sometimes when it doesn't connect each other. And for the new launch of the production, and now we see for example for the silk in the China we have the China silk, for the Iran silk, in the around the Silk Road, different areas from archaeology sites we find this one, and also we painted pottery. We have a very beautiful pottery, 7,000 to 5,000 Iran. This area also the pottery. May there possibly connected or not, we don't understand it. Also the crops, we see the center is here in the diffusion to step by step to East, and change the life of the East Asia of the people. And at the same time, we a group that try to understand the astronomy from the China, the astronomy, and from the also from the astronomy of the pulse, and there are some connection, and the new launch along the Silk Road also dispersed. This is the group by for the Vega. Ugury, the region, they try to understand this region. It is Travis' work in the group, close connection with this different age. No longer was the size technology developed, and I see combine this one. And this is the basic, and then we can understand it because different areas, what the seismic knowledge is there, and then we can compare it. And at the same time, this is also something for we call the Silk Road as a skilled protected hypothesis. And people move it, they have knowledge along the Silk Road, they have knowledge to different regions. And also this is one example is supported by ATES, and the scholars from China, Mongolia, and Russia try to understand the T route, how T route from China to part of the public of the Russia areas. And finally, we try to understand the climate, also the group, vocal group, try to understand the climate. This is the climate, the temperature, and the precipitation, and then we see all this area gets warmer in the Ural continent, but the precipitation is quite different situations. Especially we understand it for the Central Asia and the West Asia with the opposite changes during the global warming. When area gets more precipitation, more humid, and in the West Asia gets dry situation. And the same times we try the big lake is a problem. For example, the LC, you see it gets smaller, is smaller, and it is 90%, lose 90% of its areas, and the lake level decreased 24 meters. Does this is the nature, or does it is because human use the water? So one water is here. You see there are so many smaller lakes. About the Central Asia, about 1/5 of the smaller lake in world is there. Smaller lakes expanded some area, but in the West Asia, the more humid, artificial, the dammed lakes. So this is the means the big lake decrease only because of humid, not nature. Because of nature, the small lake is still there. And this also one work from Chen, and try to understand why not early people connect to each other. This is find a very big joint, 6,000 to 5 years there, big joint in this area. So in the west part of this area continued, but later this is get much younger for all across the Eurasia continent. And finally, we also see for the Aya people, we move it to the Siberia, and why they should move it to the cold area, because they are warm during the time 5,000 to 4,500. We use different lake sediments to find the less one. This is public nature communications. We see because the climate also push the people move it to less areas. And so this is the basic the recent years progress for last one. This I already sure that this published already this morning published. Thanks for your attention.
Actually, we still have 5 minutes, so. I know, but we have questions here, or we I forgot to ask either have questions, sessions, or we have 5 minutes. So I think I would take the liberty, and if anybody has a question, you can use this 5 minutes for questions or comments. Yes.
From East Asia to Europe. Do you think the 3 roads work at the same time or different times? From east to west or west to east? Silk Road. There are 3 from north, middle, south, Tibetan Road.
That's the difference. From the north part is quite early, because in China we already find the core is almost 5,600 reading layer, and But the oasis route much later, is less than 4,500. The Tibetan Plateau Silk Route is even younger. Yeah.
Okay. Are those three worked together recently? I mean, in recent several hundred years or in 1,000 years?
Yeah, we have the archaeology sites. We data the archaeology sites and get the information is less.
Great, thank you.
Any questions or comments, please?
Thank you, yes. Depictions of the Silk Road, the lines on the map, never seem to go down to the coast, or very rarely seem to go down to the coast. Is it really the case that maritime products were not traded along this system?
Yeah, you mean the coastal area?
Yeah.
Yeah. Because we most work there, we traverse the connection with the European and the coastal area. There are a group of people also done works, and the early time even suggest from the steppe route, like direct wheat direct to Shandong area, where the earliest crop for seeds for the wheat is the Shandong, 4,500. And so still there are some we didn't know what happened. One suggestion is because the early herdsmen use take the wheats directly through the steppe route to the east coastal area of China. So use the coastal area early for wheat, based on the present data. Yeah.
Other questions, comments? We still have 2 minutes. Okay, so please.
So thank you, Professor Chen, for the detailed introduction for ATES. So I noticed that so far ATES mainly focus on the continent route. So do you have any plan to extend it to marine Silk Road?
Yeah, we are mostly focused on continent. In the future, I think we should also do something, because also after almost something 1,500, the Mauritian route also developed, especially after 1,000 years, and the more important for the ocean routes. Yeah.
Okay, so one last question or comment? If not, so thank you very much, Professor Chen. Thank you. And we can go to the next speaker, is Michael Meadows. The title is From Past Climate to Future Pathways, integrating quaternary records into, I'm sorry, it's other page, into sustainable development along the trans-Eurasian corridor. Please, I'm sorry, just.
Well, thank you. It's a complicated title, and it's the kind of title you put together when somebody asks you to give a presentation at a conference, and 6 weeks later, when you come to write the presentation, you realize, what have I done? But roughly speaking, we could translate it into more accessible English. What can the past tell us about sustainability? Is it useful for us to know about the past? Let's hope I get the arrows right here. Yes. So that's the roadmap. I'm going to start with perhaps being a little bit philosophical, and this person's very well known, at least to most of you in the Chinese part of the audience. But of course, globally, Confucius, as you know in the West, or Kung Fu, had many, many sayings, but one of them was this, and that is, you should study the past if you would define the future. And about 2,500 years later, I said it a slightly different way in a paper published in Progress in Physical Geography about going forward, looking to the future, if you like, looking backwards. So there are some very clear scientific reasons why we should look backwards. And essentially, the past is a benchmark, as it says there. It's a kind of reference point, and it enables us, if nothing else, to distinguish what we might think of as being natural from what we might think of as being caused by humans. The problem with this is that the instrumental record, what we know about, for example, climate, is very, very short in the grand scheme of things. And in fact, it covers a period that's already been substantially altered by human activity. So it's not a particularly useful benchmark, and we need, in other words, evidence to go much further back in time than that. And of course, this is particularly thrown into light by the fact that we face what some have called the triple planetary crisis of climate change, pollution, and biodiversity loss. So these changes can be expressed in terms of different dynamic behaviors. As you see on the right-hand side there, things like variability or transitions from one form to another, or resilience in some cases. And they're all influenced by complex feedbacks. So we don't really know, in fact, how ecosystems will respond to future change. So evidence from the past is required to help us understand this more comprehensively. So I just put a quick list together of reasons why we need to look back. We get the idea of baselines in terms of environmental parameters. We can see how ecosystems respond, whether they're sensitive or whether they exhibit resilience. We can, as we've seen already in the previous presentation from Professor Chen, see how evolution of human environment interactions emerges over time. We can reveal longer-term processes, physical, environmental, and biological processes. Perhaps we can observe so-called tipping points. We can see the responses of ecosystems to climate change in the past, and of course, more recently, to disturbance. Carbon's a big issue, of course, these days, and we can see changes in carbon storage over time if we look back. We might be able to, we certainly can identify analogues, periods of time perhaps when the Earth was warmer or as warm as it is now, to see how ecosystems were responding then. It's not a particularly useful the analogy idea, but it has been tried. And then finally, we might think in the context of the triple planetary crisis of seeing whether or not what constitutes a so-called safe operating space as in terms of way environments have changed through time, to perhaps try and re-establish those going forward. So they're the scientific, I suppose, motivations for looking back. What do we have in order to look back? And Professor Chen has also introduced us to several of them, but we've got an expanding toolbox, actually, of methods that we can apply to this particular problem. That's just one summary slide. You might be able to find your pet method on this slide. If you can't, come and tell me about it. I'll happily add it for future presentations. But essentially, we're looking at developments in terms of chronology and dating precision. We've got an expanding range of different kinds of biological proxies, from very traditional things that I did my PhD on, like pollen, through to more sophisticated, what you might call biogeochemical proxies, like GDGTs and so on. And then, of course, traditionally, there are geochemical and mineral proxies. Remote sensing is increasingly important, of course. And then, as Professor Chen pointed out, we also interact with methods that belong more in the archaeological arena, so that we can explore human environment processes. And then finally, last but not least, certainly, modeling and data integration and the use of AI and the kind of benefits that gives us going forward. So we've got a good toolbox, and one that's getting more full all the time. So what I would like to do in the next section then is to just provide you with a few snapshots of these changes in time, and some of them I've been involved with personally, some not, and looking at different timescales, from longer sort of quaternary timescales through to what might be called the Anthropocene. And I'll start with this one. The first example comes from a study that's currently underway with a postdoc of mine at Nanjing University. And it's a study of various environmental proxies on a sequence of sediments from Yulang Lake in the Bojie river valley, which, as you can see on that map, is sandwiched between the Loess Plateau to the north and the Qinling Mountains to the south. So it's an important site from that point of view, geographically located. It's also important because it's produced a very extensive sedimentary sequence that is some 660 meters of sediment in that lake, and it reveals, in particular through compound-specific carbon isotope variations, different sources of carbon in the sediments changing over time. But also it reveals, crucially, the periodicity that's evident in those squiggly lines that you can see there on the left-hand side, which is, if you like, the raw data set plotted against time. And this is more than 2 million years of more or less continuous sedimentation. When we resolve those raw data, the tuned age model on the right now shows, and is compared with the global eccentricity curve at the bottom there, it shows a very strong match. And what you're seeing here is an orbital cycle, the long orbital cycle of just over 400 million years. Now that clearly is before any of the Silk Road processes that we're talking about mostly in this conference actually emerged, but it is nevertheless an indication that there's a long-term pulse here in this part of the world to environmental change, and certainly it's affected the position of and the intensity of the Asian monsoon, switching on more, switching off at some other times in response to these orbital periodicity changes. So I think understanding those sort of longer-term processes is a key, though it may not be directly applicable to sort of day-to-day decision-making in terms of sustainability. If we come to a shorter time scale, let's think about the late quaternary here, special issue of Global and Planetary Change, published just recently with our colleague Lu Huayu as the senior editor. This goes from orbital scales of change to millennial scales. And this provides, this particular publication, there are some 20-odd papers in there, a really useful synthesis, I think, of how the climate and other environmental characteristics of the Silk Road region have fluctuated on these millennial timescales. And I'll just give you one example, and this is a modeling approach. So it refers, in a sense, to a product of that last box on the right-hand side in the methodology slide. It's founded, in this case, on a pollen database of some 5,000 samples distributed very widely across China, of course, and it's used here to calibrate temperature and precipitation with, I think, a pretty high degree of precision. The temporal sequence of temperature shown here on the right for 6 regions of China illustrates how the precise timing of events, in this case the Holocene altithermal, used to be called the Holocene optimal, I think, but nevertheless it's not particularly optimum for some things, so we'll call it the altithermal. It's the highest temperature point, at least until maybe recent times, in the Holocene sequence, and the timing of that varies across these different regions, and you can see that it starts relatively early in the northern part of China and varies in its precise time as you go down. So the lesson that's learned here is there's quite a strong degree of regional variation, which perhaps should not be a particular surprise, but understanding the reasons, the mechanisms underlying those regional variations, I think is a very useful way of exploring, a very useful lesson that we can learn by exploring the past. So if we look at that, it's from the same paper. In this figure, we're seeing temperature at the top and precipitation at the bottom, and different proxies in this case. Each of those graphs has got 3 or 4 different proxies, and for the most part, you can see that there is parallels, and they mirror each other quite well. But there are some differences, and between some of the proxies, critically, and they're shown, I think, better in this next slide, in which these are plotted in a graph form. That's just for the Holocene, so it's just for the last 10 or 11,000 years. And it's rainfall on the top for mean annual rainfall, and it's June, July, and August in the bottom set of graphs for, from left to right, China nationally, the northern part, and the southern part. And what you can see in the black line there are the traces, the modeled, I guess, reconstructions from the traces experiment. And the red line is the modeled data based on pollen. And you can see there are quite substantial differences in some cases, not only between the traces and the modeled pollen reconstructions here, but also in different parts of China. So if you look carefully at the top there, you'll see that, oopsie, gone too far. On the right-hand side, you'll see that for southern China, the arrow continues, that's increasing rainfall, in other words, through the Holocene, continues into beyond the mid-Holocene, beyond that altithermal, whereas in the north, the rainfall actually starts to decline relatively early on in the Holocene. So these different trends in different regions, I think, are important to explore. The next example is one that I have been involved with, and it's, in a way, is partly the reason why I asked Professor Chen the question. Did we not think about the Silk Road at any stage going down further to the east and maybe interacting with the ocean? But this case study is on the Yangtze River Delta. It's on lake sediments from the Taihu Lake. You can see the map there on the left-hand side. This is clearly one of the most developed parts of the world, let alone of China. And in this case, we're dealing now with a much shorter-term variation, and one that's clearly strongly impacted by humans. So we're down now at the perhaps centennial, and in fact, in this case, decadal and even annual changes. Just to emphasize how things have changed in this part of the world, here's a temperature curve, and clearly towards the right there you can see, as you would expect, substantial global warming. And that's been paralleled with massive increases, or substantial anyway, increases in population, and of course, very rapid economic growth. So this study published in PNAS is a multi-proxy analysis of sediments from the lake. And it attempts, I think, to try and tease out what are the driving forces of change in this system. And I won't bore you with the many diagrams of the various proxies that are in this study. Suffice to say that at least for the last 120 years, we've got a pretty detailed record of what's going on here, obviously in terms of socioeconomic development, as you can see, and an evolution in the way in which this landscape was being utilized, from extensive and perhaps even quite informal farming in the early part of the 20th century through to much more intensive agriculture, followed then, of course, very quickly from the 1950s onwards by industrialization and urbanization, and perhaps an indication on the right-hand side there of a shift towards China's dream of an ecological civilization. So if we think of it in terms of what's been happening in the lake, it's got a real problem, Lake Taihu, with eutrophication, and they really are battling with these algal blooms, and they're still battling with them. And you can see it in the data of primary production there in the green blocks there, just increasing as time goes by. But there are some indications, perhaps, of environmental improvement, maybe in the Taihu Lake basin, if not in the lake itself, where towards the end of the last 20 years there, we might see a decline, for example, in the pollution loading index, and a decline also in erosion intensity. So some indications maybe that environmental policies are working in this part of the world to improve environmental conditions somewhat. And in fact, we put together a coupling index for that paper, and it shows a distinct improvement, or a distinct decoupling, actually, within the last 2 decades as the population and the economy continue to increase. The environmental degradation becomes decoupled from that. And it is, I think, a strong indication of partly of government policy, but also relocation of heavy industry from this part of the world to other parts of China, particularly in the north. And so to the fourth bullet point and the talk, and that is to, and again, Professor Chen has given us many examples of this in his previous presentation, but I'll give you one from the coast, and again, why I asked the question about the Silk Road and the coast. But this, I think, is a fascinating story, archaeologically, of the rise and, quite rapidly in the end, the fall of the Liangjiu culture. So this is a Neolithic coastal society that existed for 1,000 years or so, around about the mid-Holocene onwards. An extraordinary civilization, actually, with social stratification, a kind of city even in Liangjiu. And it's been described as the earliest state in East Asia. It's actually an icon of Chinese civilization. Economy based very substantially on rice cultivation, but also many, many, many other things in the sophisticated economy that existed then. But it collapsed pretty much overnight, around about 4,400. And given the fact that it's at the coast, it's not surprising that probably the most important element of that, though there are some crucial climate changes around then as well, probably, would have been the rising seas, the invasion, if you like, of the ocean. Salt water, even if it didn't actually become the ocean, the land was effectively became salinized, and rice cultivation was virtually impossible. And that's with one exception, and that's Daxia Island, which you can see in little black block labeled C there, to the south of Hangzhou Bay. And that Daxia Island settlement actually persisted through that 4,400 BP collapse that happened pretty much everywhere else in those Liangjiu settlements. And it was an adaptation, an innovation, actually, that led to the development of large-scale sea salt manufacture. So the population on Daxia Island was actually seeing the sea level rise. They built mounds that you can see examples of there on the left-hand side at the bottom. They built mounds to raise the levels of these settlements above the sea level, but they also started to utilize the resources that the ocean had, which of course predominantly not only fish and so on. They were utilizing the salt, and it appears to be on an industrial scale. And that led to their survival, not forever. They too eventually dissipated, but nevertheless it is an example, I think, a very nice example of adaptation and innovation. Perhaps gives us some lessons, some hope that we might be able to also to adapt and innovate in ways that cope with the issues related to climate change and other environmental problems, notwithstanding the fact that we need to mitigate as well, not just adapt. And that's essentially the summary diagram of all of this. You can see the sea level curve over on the left-hand side, and not surprising perhaps at the rate of sea level rise at that time, that this had a major impact upon these coastal communities. But there was this population at Daxia decided to do something different, and as a consequence, surviving this environmental stress. And so my final slide, and it's just one slide, is are we able to use any of this to give us some clues as to how we might make the future sustainable? Well, I hope that the answer is yes. We can use the past, if you like, as a kind of prologue, how these quaternary, Holocene, and Anthropocene insights inform sustainability for the Silk Road. And, well, at the sort of quaternary scale of things, what we're seeing is mostly natural variability on orbital to millennial timescales. We're seeing these glacial, interglacial cycles. We can see them in quite some considerable detail, as many in the audience here will know, because they've done the work. But we're also seeing shifts, substantial shifts in these monsoon conditions. So there's a kind of long-term pulse there, which we certainly need to know about. When you come to the Holocene, we've still, of course, got natural variability at millennial timescales, but we're now starting to see processes that involve interactions between humans and the environment. And again, Professor Chen, farming, herding, adaptation, and maybe innovation, the innovation that we saw in the case of the Daxia population in the previous example. Then we come to the Anthropocene, which is a pretty sad tale at the moment. We're into decadal or annual variations. We're into human impacts, of course, which have exceeded natural thresholds. We are beyond the safe operating space in a fair number of those planetary boundaries that we were introduced to a few years ago. We have the triple planetary crisis of climate biodiversity and pollution. We haven't, I don't think, in many cases even begun to accept this, let alone address it. Maybe as scientists we've accepted it, but I'm not so sure that the politicians have, all of them have accepted it. And so then, in that case, to the present day and the future and how this engages ATES. Well, there are many challenges, and Professor Lutebacher also introduced those: water, food insecurity, land degradation, extreme events. But we have some strategies: early warning, resilience pathways, integrated knowledge, science education. But I do believe that an understanding of the past and the way that's impacted ecosystems and indeed ourselves is a very useful approach towards achieving that sustainability in the future. So with that, I will say thank you very much indeed.
Well, I'm sorry we don't have time for questions because it's a little bit over the time. So I would ask Professor Bojie to give his speech on evolution of ancient ecological system in China's Loess Plateau.
Good morning, ladies and gentlemen. Thank you very much for Mr. Chairman. Just Professor Chen is give the story from the Asian Silk Road. Is Professor Meadows is a link, is the past climate change and is environment change. I would like to give the story. Is happen is the past 50 years. It's in Loess Plateau of China. So as you know, it's a Loess Plateau is located in the center. North center is China. It's also about 600,000 square kilometers. Important geological unit is in the world. Also is the semi-arid and arid is climate, is a water shortage, is a diverse, is a landform. Also is very serious for soil erosion. It's in the world. So along with the long-term cultivate and high distance is the grazing, is the land degradation is very serious. So is the local people is the poverty. Also is a extreme climate change and is extreme is a poverty. It's our group is a study 1,000 years is a change in this is area. Is about is the population is still increase is no. Also is agriculture and is the first is the change 1,000 years. But we divide it is 5 phases stage after is the 1,000 years is the change. But now I give a station we just focus on the establish is a new China. It's after 15 or 17 years is a change. So it's what is relationship is a human and nature system in this is regions. It's very tight is a relationship. It's in here. Its use is only is 6.7. Its land is a support is 8.5% is the population. That means is average is the population density is over is the average level for our countries. So establish is a new China for Chinese government pay more attention for food security in these regions. So agriculture, development, and soil and water conservation as the main tasks in these regions. Some particularly is after is 2,000 years, we pay more attention for ecological restoration
is the plantation is in this is the regions. It's an ecosystem and the land cover. It's a dramatic change. After 20 years, it's a restoration. I give you, share this you. You can find this slides. It's the greenest. Is the change is the greenest. It's leading our Chinese ecosystem change. In this is the regions. This is the slides that show you is the different phase. Before is the 1980s, a lot of steep slope farmland in this is area. But from the 1918 to 2000, it's a transition is the stage. We have the several is a project, pay is a small catchment, is rehabilitations. After is the 2000, a large number of the area for ecological restoration in this is the regions. This slide show is a plantation in Loess Plateau in here. Also is the grass is recovery in this is region. So for our research, we pay long term for soil and water exchange. After is land cover change. But now we also pay attention for ecosystem services change, particularly for carbon sequestration with the relationship with the water issues. Because this is a region, is a semi-arid regions. We need to use the scientific issue to garden is for ecological restorations. So first stage, we are pay more attention for land use and soil erosion. But second, we are for the ecosystem services, optimize them. Also for the regional sustainable development. We are also is a monitoring is the ecosystem change from the different scale for plots, for transect, for regional. Also, we have some is a research is a framework. We are selected is a 4 ecosystem services, particularly is in the food provisions for this area. Also, is agriculture development source in China. Also, is the support is agriculture, food security is number. We are also focused on the soil conservation and the water years and the carbon sequestrations. So our selected is from the land use is patching and vegetation community. Compare also is a structure of this is the regions. For ecological process, we are pay the vegetation dynamics, is the soil erosion change, is the carbon with the water conflictivity, is means ecosystem trade-off. Ecosystem services trade-off and sediments is a change in the Yellow River. Also, we link with social-economic development for human well-being. So this is the measurement for investigation is from the different is the scale. We use different approach. This is the for soil moisture dynamics in the plot is the scale. This is the sample flow for the standard is the water balance is the garden for the plantations and the ecological restoration. This is for our is the transect is the investigate for the is the water with vegetation in the community. This is a results is from the different scale from plot scale. We are find which is typical is the types for restoration. We are from the transect scale. We find is what is the suitability for the different community for different ecosystems. Then we give some is scientific support to the local government and the central government. This is the soil water change after our about 20 years is the monitoring. We are selected which is the best. You can find shrub land and nature grassland is better for soil conservation and water. Saving is the water for this is regions. After is plantations, soil erosion is very good is the performance along with ecological restoration. Soil conservation is the increase is dramatic in here. Also, sediment is the reduction in here and the Yellowstone. We development some is the equation for identifying which is the driver force for the sediments reduction in this is regions. You can find from after from 1914 to 2000 to now is the sediments is dramatic change is after the several times. So is before is our rehabilitations is landscape engineering is the track dam and the terrace. It's good is a measurement for control erosion and control sediments, catch sediments. But after is the plantations, for vegetation restoration is the main driver force for the sediments is the reductions. So also for carbon and water relationship, we find which is the best is for the carbon with the relation in the south part and in the north part from the ecosystem and the landscape. You can find after is the ecological restoration, carbon sequestration is the increase from the source to the sink. In this is the regions for Loess Plateau is not only for the plant but also for soil. But we also find is the ET is the increase after the plantation. It's also is the soil moisture and the runoff is decrease. This also is a problem in this is the region. We should be balanced and trade-off. What is the carbon with the water? We still have some research and suggestion to what is the suitability, what is the sustainability is for this is the regions. Our published is paper in the Nature Climate Change. This is revegetation is China's Loess Plateau is the approach. Sustainable is the water resource limited. We give different scenarios. Also think about is the climate change and the social economic development in the future development. We also study what is the different is the relationship between different ecosystem services. For example, for productivity is with water years. Also is the vegetation productivity with soil erosion. Also with water regulation is a different relationship. We also development is Optime is modern. For Optime is ecosystem services. We think of a database, also is a model base, also is a scenarios analysis, and the multi-Optime is the planning is the modeling for the where can output is the different scenarios for government for suggestions. Look at is the achievements and after is the plantation is a dramatic change. For example, NDVI is in 2003 is a tipping point is the change. Before this is regions is NDVI is a low of the national average levels. But in 2003, after 3 years, is the rehabilitations is over is a national average level. But also is vegetation coverage is a change, is dramatic. The cover from the 30% to the 16.8 is a percent is no. Also, social-economic is a change. You know, is for grain output increase is about 16%. Also, urbanization is an increase. Is a farmer is a income come from the different source, but not only from the farmland, but also from is a labor immigration and is a non-agriculture industry in the local cities. So we are also analysis is what is metal company is from the different outposts with Also, the Chinese government pay is the money and the food for local government. Ask is the local people for ecological restoration. After is the 20 years is restoration, you can find for this region from the poor green to more green, also for poor green to the more green. But not only from this is the Nanjing, from the green to green, the program, but also along with the technology development and economic development and also urbanization in these regions. How to escape is a social ecological trip in this is region. We are selected some indicator compound the system state index is for the is a different change. Also, we can use is a social ecological network is for different phase. What is the main driver force in the different phase? You can find is a change after is 30 years is a change. We also analysis is a change of the socio-economic elements. For urban is a rural population. Also increase is a rural household income and the increased diversity of the livelihood of the rural peoples. Also is we are select some ecological elements is a change for soil erosion, also for ecological restoration. For Yellow River is sediments is a change for this one. You can find we can divide it is three stage. Is from the 1949 to 2020. We divided the three stages. It's quite different for three stages. First phase is from the 1949 to 1981. This is the local, social-ecological systems. It's the local, it's in the tribe. It's the main is elements, is the population pay more is attention is for land, is only for food is the solutions. But for second is reactions to the tribe. That time is the urbanization is a rate replaced to the rural people as the main important network is a node. Also link very weak with the other elements. Third is the phase escape is a tribe. This is also is urbanization, is Nanjing, is labor, immigration, and other is investment and income can be changed. This is the systems, is a change, is for development. So from our story, you can find is after is 20 years is rehabilitation. Loess Plateau is happen, is a dramatic change. Is a similar, also similar is the social ecological traps. It's also observed in many other regions in the world, particularly in the developing is the countries. From the Loess Plateau, we can summary with use the three pathways to disrupt is a trap situation. One is the implementation, size specific engineering management. For example, first time we can use terrace and a check dam is a solution, is a food problem. Hungry is the problems. Second is a promote livelihood, is a diversity and urbanization. Third is the investment, pay more attention for ecological restoration is a program. Also, escape is a tribe, is not end of the story. But now we are focused on the sustainability. For ecosystem, resilience is a promotion against is a risk of the climate change and social economic change. Thank you very much for your attention. Thank you.
We have 2.5 minutes for questions and comments. Yes, please.
Thank you for this very interesting presentation and this extraordinary work you have done there of greening. But greening is based on water, so this is a semi-arid area, you said. So where does the water come from for these new plantations, new forests? Did you dig wells? Did you dig new canals, or is my question?
Yes, it's a good question. You know, it's a water shortage in this region because this is a semi-arid. But in the farmland in these regions, we are also foreseeing water technology development. Also, most is the land is from the rain, is wheat is agriculture. So that is some is water. It's a drain from the Yellow River, from the Yellow River. But still is a problem. Most is the Chinese government have the initiative from the Yangtze River input is the water to the Yellow River. Solution, this is the problem. Thank you.
Other questions, comments? So if not, thank you very much.
Thank you. Thank you.
Okay, so next speaker is Professor Suzanne Leroy from the Aix-Marseille University, France. And the title of her paper is Palaeoenvironment and Palaeoclimate since the late glacial from the Caspian Sea and its eastern drainage basin.
Thank you. Good morning, everybody, and thank you very much for the invitation. I'm very happy to have the chance to present my results. Oh, the pointer is not... Oh, the pointer to show on the screen. Okay, thank you. So I'm going to take you from the Caspian Sea to Kyrgyzstan, Lake Issyk-Kul, via briefly the Aral Sea. So basically we are going to follow the trend of the westerlies. And you will see there are sometimes some influences from other climatic forces like ANSO or even the Indian summer monsoon. So first, the Aral Sea, the Caspian Sea. The Caspian Sea is a very large sea, and most of its water is coming from the Volga. So the Volga drainage basin extends very far north, nearly up to Moscow. To the east of the Caspian Sea, you have a huge desert, and in the south here, very narrow area, you have a place with very high precipitation. This area is called the Irkanian region, and you can see that even during the last glacial maximum, it still had a green spot here, meaning that the forest vegetation managed to survive the extreme of the last glacial maximum. So very diverse environment around the Caspian Sea. The Caspian Sea level has been changing also, not only over millennia, but also recently from 1840 to the present, with a minimum in 77 and a maximum in 95. So when such changes occur, especially in the northern basin, huge area may be flooded or emerge. For example, in the last 2,000 years, there was an area the size of Belgium appearing and disappearing. And the rate of change is very fast also. It seems to be 100 times faster than the global sea level change. What are the causes? Of course, climate is important, but in the case of the Caspian Sea, we have to take in consideration also important change of hydrography. which rivers are flowing into the Caspian Sea. Of course, not in the 20th century or 21st century, but further back in time. Here is a compilation of what we know of the Caspian Sea levels from the last glacial maximum to the present. And you can see that according to different authors, we have a lot of different information. Of course, most of them in this pinkish area, during the last glacial period, the levels were relatively high, especially with the melting of the Eurasian ice sheet. Then, at the very beginning of the Holocene, we have a low stand called the Manji Slack that most authors managed to pick. And then here, a blue a period where I'm very interested in, because some people say it's highish levels, others think it's lowish levels. So that's very important to understand. Unfortunately, this literature review means that shows that we don't have an agreement. We have also metadata for the data we have. Near the coast, that's where most of the outcrops come, and when there is a low stand, we have a hiatus, so lack of information. Basically, we have no complete records. What are the methods we could use to inform us about Caspian Sea levels? Of course, lithology, when we have continuous cores. Traditionally, mollusk and ostracods were used, but no forums, so oxygen isotopes information is very complex and not well known. So we are looking for a new method, and I propose here to use dinocysts. So dinoflagellate cysts are a protist organism, and they can show paleosalinities. When we started working there, we had actually to start by doing taxonomy, because many species, some genera, didn't have a name, so it was a slow start. But we did that taxonomy, especially with taxonomy with Fabienne Marais, and then we could start using them. And this taxonomy, actually, you will see on the next slides, is now widely used from the Black Sea to the Aral Sea. Those protists can tell us about paleosalinity, sometimes surface temperature, a little bit about nutrients, or even if the water is turbid or not. And we combine that with the more traditional method of pollen and spore that we find also in the Caspian Sea. So combining those two methods, we have in the same samples information on what's happening in the sea and on land. So this is briefly the area of the Parathetis, so in the Pliocene and Oligocene. So the Caspian Sea, the Aral Sea, and the Black Sea were part of this Parathetis. That's why we find the same group of organisms, those dinoflagellates. So this is a typical diagram of dinoflagellates. The percentage here of different species. For example, here is the last 5,000 years. And if we turn this diagram, actually, we can propose that we have like an approximation of paleo sea levels. When we have more low salinity assemblages, it's a higher water level, the blue line. And when we have more brackish ones, it's actually lower water levels. But we cannot, with the information we have at present, quantify. It's just a qualification, if I may say. And the Caspian Sea levels have changed, I said, not only because of climate, but also because of hydrology. And here we have a map of the last glacial maximum. At some point, the drainage basin of the Caspian Sea received water from the melting Eurasian ice cap. You can see here in this area the superposition of the two. So for a while, this water was flowing in the Caspian Sea, and then when the ice cap retreated enough, it was flowing into the English Channel and the Atlantic Ocean. Of course, this had an impact on the Caspian Sea with a drop of this water level. So very important is the time of overlap and the time when there was no overlap. So at present, And for a long time, for many millennia, the water was coming from the Volga. And then we had a direction of the flow from the north to the south. Especially in the south, it's warmer, we have more evaporation. This is the result of my work on a series of cores from the last late glacial to the present in the middle basin and the south basin. And working on those two basins allows us, with this reconstruction of paleosalinities, to see the direction of flow. So mostly it's from the north to the south, those black arrows here. But this period here, at the beginning of the Holocene up to 4000, we have actually this red arrow that shows that actually we had an inverse of the flow. So how is that possible? Well, for a long time, the water was coming from the melting of the Eurasian ice sheet. And then this ice sheet disappeared. We are not connected to it anymore. So where is the water coming from? So in the Russian literature, often is mentioned water coming from the south. But what does it mean, the south? Is that the Elburz Mountains in Iran? Is it the Kura River in Azerbaijan? Or is it something else? And I suggest here, with some other researchers, that actually it comes from the Amou Darya. The Amou Darya is the river that flows nowadays in the Aral Sea. But actually, if you look at the geological times, we can say that the Amou Darya actually is a Caspian river, not an Aral river, because most of the time, through the last millions of years, it was flowing mostly to the Caspian Sea. And I suggest that during these periods between 8,000 to 4,000 years ago, the Amou Darya was the source of water in the south of the Caspian Sea. The Amou Darya, of course, comes from the Hindu-Kush Pamir area, so it's a completely different, under a different climate system than the Volga River with a more temperate, even temperate cold latitudes. Nowadays, of course, we don't have the influence of the Indian summer monsoon at all. However, if you look at meteorological data, it seems that when the Indian summer monsoon reaches the Pamir in the Kush, it warms the air so much that it goes over the watershed, reaches the periods where the area where the Amou Darya has its sources, where there are glaciers, and those glaciers, because of warm air nowadays, start melting more. So this is the present-day system. But at the beginning of the Holocene, we know that the Indian summer monsoon was much stronger, and most likely it went over the limit of the crest of the Pamir and fell into the Amou Darya drainage basin, and that would explain why the Caspian Sea level from 8 to 4,000 years ago was much higher. But of course, this has to be confirmed with other studies, not only dinoflagellates, but for example, strontium ratio and so on. Another interesting influence on the Caspian Sea is ANSO, or even NAO. So this is a study done by colleagues who are meteorologists, and they have looked in the South Caspian Sea at different meteorological stations over the last 55 years. So very recent study, of course. And the red curve here is the Caspian Sea level. So we had a period of fall to the minimum of 77, and a period of Caspian Sea rise up to a maximum in 95, and then it's falling again. And they looked especially at the speed and direction of winds. And it seems when the winds are stronger and coming more from the west, that's what shows here, this wind rows. Especially in 95, we have a change in the direction of the wind. So when there's more westerlies, the water vapor evaporating from the Caspian Sea doesn't fall again as rain in the Caspian Sea, but is exported from the Caspian Sea drainage basin and goes further east. For example, reaches all the way to Kyrgyzstan or the Chen Mountains. And this would be one mechanism to explain the Caspian Sea level fall in 95. And in 95, when in addition, we looked at NAO and ANSO, it seems that those two global mechanism work together. So when they are antiphase, they have less influence, but when they work together, they have also an influence on the region of the Caspian Sea, and that's an additional forcing on the position of the jet stream, and the whole then atmospheric system changes. Let's move briefly to the Aral Sea. In the Aral Sea, with the French colleagues, we took 2 cores, one on what was the island of Vojrosnenia, and the other one in the western part of the large Aral Sea. So the first core covers from 14,000 years ago to 5,300, and the second core from 5,300 to the present. The study is not finished, so I can already just tell you that we have lots of pollen here up to 9,700, then we have no pollen. It's not preserved because the sediment is too anaerobic, too oxic, too much oxygen, no preservation, probably too shallow, or even no Aral Sea. And then the water comes back, and we have, again, good sediment favorable to preservation of dinoflagellates and pollen. So what's happening in this period? So this is when it becomes really interesting. Normally, the Amudarya flows into the Aral Sea, but during that time, there are possibilities for it to flow to Sarikamish here, and then from there, across the Karakum to the Balkan Mountains here, up to the south basin of the Caspian Sea. And that explains probably why we have, at the time of the high levels in the Caspian Sea, low levels in the Aral Sea. So it's a flip-flop situation, and the Amudarya is changing from one to the other. So let's move further east to Lake Issyk-Kul in Kyrgyzstan. So this lake receives also more of its precipitation with the westerlies coming from the west. Over the lake, the clouds are recharging in humidity, and then they break on the eastern part of the Tian Shan here, Kyrgyz Tian Shan, and we have more precipitation on the east than the west of the lake. On both sides of the lake, we have a very nice belt of Picea forest. You can see it here, between the lower steppe and the upper alpine meadows. So in Kyrgyzstan, like in many places in Central Asia, you have glaciers, and those glaciers nowadays are melting at an alarming rate. And downhill of those mountains, you have the lowlands, often depending only on meltwater from those glaciers. So this is a situation which is not in balance at the moment. We took 2 sediment cores in the lake. Here, the red points. You can also see that the main rivers are coming from the east, which is the more humid area. But something really interesting, nowadays you have the Shu River coming from the plateau here, that bypasses the Issyk-Kul, turns just before, and turns west. So this river actually comes into the Sirdarya and then the Aral Sea, and at some point the Aral Sea was connected to the Caspian Sea. The Caspian Sea was connected to, at some point, to the Black Sea, and so we can nearly say that Lake Issyk-Kul was connected all the way to the Atlantic Ocean somehow, through this system of rivers existing, not existing. So let's go back to those the results of the 2 cores we took in the lake. The first one covering the last 5,500 years. That's in Lake Issyk-Kul, and we focus on Picea because Picea is a very good indicator of climate. It is a tree that requires humidity and also relatively cold climate. So if we look at the percentage of its pollen and also the concentration, we can see there are 5 periods, the gray bands, where this Picea is more abundant, and it means that the belt in the forest actually has gone down. So we have cooler periods and probably slightly more humid. A colleague published a nice diagram in a lake just above the Palaeoclimates belt in the drainage basin of the Issyk-Kul. And when they have lower values of Palaeocia, we have higher values lower down. So we can see very clearly that the whole belt of this forest moved down into closer to the lake. But was it exactly close to the lake or not? We don't know yet. And for this, we have acquired a series of modern samples in the lake with Bernd Wagner and around the lake myself, which we are analyzing at the moment. And we have several transects through this Palaeocia belt, which is here, up to the base of some glaciers. And we hope that we can establish much more clearly with that periods in the past when this forest was close to the lake or not. Also, this study of modern samples in the lake could help to decide where to put a very long core covering several millions of years, because this is one of the lakes where we have huge amount of sediment. It's a tectonic area, so we have a basin that has accumulated a lot of sediment. The second core tells us a different story. This is now from 4,000 years to 13,000 years ago. Before 10,000 years ago, we have a very strong influence of runoff. Of course, we have the melting of the glaciers at that time. Not only we can see that because we have signs in our record, but also what's really interesting, ice core taken in the glacier nearby indicates that the soil below the glacier dates from that period. So it was a very dry period, and the ice was melting fast with the water reaching the lake. After 10,000, it's a different story. The pollen shows an increasing humidity, whereas the oxygen isotope shows a decreasing of the humidity. So this is apparently incompatible. And for that, we read some Chinese literature that proposes what's called the reconciliation hypothesis. The pollen comes from the area around Lake Issyk-Kul, whereas the oxygen isotopes come from water from the top of those mountains, from the glaciers. And these were influenced by the monsoon at that time. So again, we have the story of combining the different climatic system. The westerlies have an influence, and monsoon also. So, yes, conclusions. Still a lot of questions are open and work remains to be done. I would like to improve the calibration of diagnostics in the region of the Caspian and the Aral Sea. I would like to understand better the source of water in the early Holocene in the Caspian Sea and this balance between the two seas. And of course, for that, we also need to have more data sets, not only in Issyk-Kul, but around the Caspian Sea and Aral Sea. Thank you very much.
Time for questions.
Okay.
Thank you very much. So our last speaker in this session, I would like to ask Professor Maria Fernando Sanchez-Goni from the École pratique des hautes études, Paris, Sciences Lettres, and her title is Warm Ice Ages Changed, Climate Cycles and Potentially Impacted Human Civilization in Eurasia.
Okay, thank you very much for inviting me to give this talk that presents my work that focuses on how warm ice ages changed climate cycles and potentially impacted human evolution in Eurasia. We are far back in time now. Geological archives show that the Earth's climate has been submitted to large changes between warmer and colder periods. This forced originally by changes in insolation. I mean the amount of the energy that the Earth, the top of the atmosphere, receives from the sun depending on latitude and season. As you can see in this blue curve, here is 5.5 million years, warmer and colder periods. But after, here, there is a key event in the climate, because you have much more pronounced colder climate, because there is a high accumulation of ice volume in the high latitudes of the northern hemisphere. And this defines the start of the quaternary ice age. Then, from 2.6, you have a succession of glacial and interglacial periods. And this curve is from the data coming from the analysis of the microorganisms living in the deep ocean. I mean, the benthic foraminifera, the data of the oxygen isotopic ratio of the calcium carbonate of the shells. Then we know that during interglacial period, we have the ice that is reduced to Greenland, and the landscape was dominated by forest. But during glacial periods, 2/3 of the northern hemisphere is covered by ice, and the dominated landscape is steppe. And this moment in which we have the start of the quaternary, there is another key human event, that is the emergence of the genus Homo in Africa. Africa was not impacted directly by the ice advances and retreats, but during the beginning of the quaternary, during the emergence of Homo, we know by different kinds of studies, the marine sedimentary sequences or biomarkers, that there was an increase in aridity in Africa. And the result of that is more open vegetation. The landscape was a kind of mosaic-like vegetation, and also the percentages of the fossil bovids is dominated by the grazing species. Therefore, the hypothesis putting forward to the genus Homo in Africa is that this increase in aridification favor the increase of the grazing species, favor the hunting by the hominins, and therefore favor also the consumption of meat and marrow and the increase of the brain. Homo evolved in Africa, and more or less at 1.7 million years ago, Homo ergaster left Africa and colonized different continents, then Eurasia. And at more or less 600,000 years before present, there is another key human event, is the emergence of Neanderthals and Denisovian in Eurasia. Why? But this moment also coincides with also a key climate event or transition. In fact, it's the end of a transition that is called the Middle Pleistocene transition, when there was the progressive shift from 41,000 to 100,000 years ice age cycles. It means that before the Middle Pleistocene transition that started more or less at 1.2 million years, the glacial cycles follow a dominant cyclicity of 41,000 years. And after the Middle Pleistocene transition, the ice age cycles were dominated by 100,000 years. You can see very clearly here that this, the glacial 16 is very pronounced and also is longer, I mean, lasting 100,000 years. And this cannot be explained by the changes in insolation, because before the MPT, you have a dominant cyclicity in insolation of 41 and 20,000 years, and before the MPT, this cyclicity is the same. You cannot see a cyclicity of 100,000 years in the insolation. Therefore, several authors have proposed different mechanisms, internal mechanisms, to explain these changes in the ice age cycles. And we are going to focus on that one, the precipitation at the ice margins. Why? Because when in the center of the ice caps, the atmosphere is very cold and very dry. There is not evaporation, and therefore you cannot have the falling of precipitation as snow. Therefore, the increase of this ice, the accumulation of ice, can be only done at the ice margin. And we focus on the end of this period, the Middle Pleistocene transition, because it's here when you have really the tipping point, because it culminates with the glacial 16, and we focus, of course, in Eurasia. The end of the Middle Pleistocene transition spanned from 800,000 to 670,000 years before present, and is a very paradoxical period, because you have warm sea surface temperature in the North Atlantic mid-latitudes, including during the glacial 18. And this glacial 18 has less insolation and less CO2 concentration than the previous interglacial. In spite of that, you have very warm sea surface temperature. We are in an intermediate glacial background condition, and there is really an ice sheet growth in Eurasia and North America, culminating in glacial 16. This warm sea surface temperature produces a lot of moisture, but still this moisture transport across Eurasia towards high northern latitudes is poorly constrained. And for this reason, we have worked in two regions. First, the westernmost part of Eurasia, I mean the western Iberian margin, and because in this case this site is directly influenced by the westerlies, I mean by winter precipitation. And analyzing the pollen, we can infer vegetation and precipitation. Also, this core has been analyzed for marine proxies, and in particular, we have estimated the thermal gradient that indicate the moisture production and the intensity and location. Of course, this site also has been analyzed for analyzed by the delta 18 of the benthic foraminifera to infer global ice volume. And this result has been compared with the record of the Chinese plateau Loess, indicating changes in the East Asian summer monsoon and in the East Asian winter monsoon. I participated in the expedition Mediterranean Outflow from 2011 to January 2012. This was the vessel, the American vessel Joyous Resolution, that unfortunately is not working anymore, but now you have the new Chinese vessel doing deep drilling, the Nanjing, and for future research. And, it was Christmas time. Then we were working collecting the sedimentary sequences. Also, we described the sequences. I was doing preliminary pollen analysis in the vessel. Also, I was counting, and at the end of my shift, midnight, I was a little bit tired. Then I analyzed in the lab after the pollen, and I found two dominant pollen assemblages. One is dominated by pollen from evergreen and quercus oak, olive tree, and pinus, indicating the dominance of a Mediterranean forest with precipitation above 600 millimeters per year. And the other pollen assemblages was dominated by herbs, mainly cenopods, sagebrush, and ephedra, that indicate a semi-desert landscape with precipitation below 200 millimeters per year, a landscape similar to the Iran and Iraq steppes at present. And here you have the synthesis of the result, in which you can see the three periods, the two interglacial 19 and 17, the glacial 18, and you can see that the Mediterranean pollen, forest pollen percentages indicate a progressive increase in the Mediterranean forest, indicating a progressive increase in winter precipitation. Still, you can see that in 18, you have more forest and more precipitation than in the previous interglacial, that is characterized by more insolation and more CO2 concentration. And what is interesting is that this, with the proxy for the oceanic moisture production and position, is indicating that the moisture production in the North Atlantic is going towards the north and increasing the production. It means that this moisture source and precipitation are moving towards the north, towards the ice margin. And this is supported by a recent work indicating that at just 700,000 years before present, there is an increase in the incision rate of the Seine Valley in northern France. I mean, more or less 50 degrees north at the ice margins. Then all this precipitation is falling as snow, increasing the ice volume. And when we compare what is happening in the East Asia, you can see that the curve of the East Asian summer monsoon also is showing that the glacial 18 is characterized by more precipitation than the interglacial 19. It means that also in this region we have more precipitation during 18 and also still more during 17, indicating also that there is more precipitation at the ice margin, because we know also by other marine proxies that you have an increase in the sea surface thermal gradient between the tropical west-north Pacific and the subpolar west-north Pacific. It means that in all this period, you have really an increase in precipitation at the ice margins. And other researchers have tested this hypothesis of the precipitation at the end of the MPT, and they have used an atmospheric ocean general circulation model called COSMOS that is forced by the strengthening of the AMOC, the Atlantic Meridional Overturning Circulation, that we see in the record, in the palaeoclimatic record. This implies the northward shift of the moisture source in an intermediate ice volume context. And the results show that, there is an increase in precipitation, and particularly in Eurasia, in an area in which the surface air temperature are at 0 degrees. It means that this precipitation is falling as snow. But I'm speaking about ice volume, but it is interesting is the configuration of the ice sheets. And we know, based on geomorphological data and model simulation, that before the end of the MPT, Eurasia was almost free of ice. But after the MPT, during glacial 16, Eurasia was really covered, a big part of Eurasia was covered by ice. In fact, 16 is the strongest glaciation of the quaternary. And we know that the ice reached the south margin of the Black Sea, and therefore, if you add the permafrost, the associated permafrost, probably there was a north-south ice barrier that potentially produced the fragmentation of the Homo ergaster population arriving at 1.7 million years. It means that this north-south ice barrier fragmented the Homo ergaster population, and towards the east, it resulted of the Denisovian, and towards the east, the Neanderthals, as indicated by the paleogenetic data. In conclusion, we have identified this very moist and warm condition in Eurasia during the glacial 18. That is quite unexpected, was quite unexpected. This sustained oceanic moisture production moving towards the north during the end of the MPT, leading to the increasing of precipitation at the ice margin in Eurasia, but also in North America. During the end of the MPT, this process leads to a tipping point, the shifting from 41,000 to 100,000 years ice age cycles, which has governed the climate of the last 700,000 years. This north-south ice barrier during 16 in the Black Sea region may have been a key driver in the speciation process that ultimately gave rise to these two distinct archaic human lineage, the Neanderthals and the Denisovian. And testing the broader ecological effect of this ice sheet expansion could involve examining whether similar patterns of divergence and drift occur in other co-distributed animal and plant taxa across Eurasia during the same period. And this I'm inviting geneticists to test this hypothesis. Thank you very much.
Minutes for questions. Any questions, remarks? Everybody is too hungry, I guess. So it's so thank you very much again. Thank you. So I think here we can close this session, and now it's time for lunch, which is also downstairs where we had the coffee break. And we are going to resume our work at 1:30. So please keep in mind. Thank you. Bye-bye.